Good afternoon to you viewers and subscribers. Welcome back to my channel. Welcome back to another video. So in today's video, I'm going to showcase to you a corrugated steel arch bridge on the Melrose bypass. I think this bridge was built sometime in the 1970s or in the 80s, somewhere thereabout, by the Kirkvine Wildalco plant. So it is a bridge that is primarily used, I think, back when Kirkvine plant, the Windalco plant, was in operation by units of that plant traversing to and from. Because back in those days, I could visibly see vehicle going across these bridges, but it's mainly vehicle from the backside plants. So I want you to watch this video, and as usual, I am really appreciative of you if you really watch the videos until the end to contribute to my watch hours. So watch the video, and I hope you like this video. Thank you.
Good morning to you folks. So I'm here again to take you to another bridge to show you another type of bridge, and this is the Melrose bypass underpass bridge. So this bridge, from my recollection, was built by the Windalco, or back then Alkian. So it is the Windalco Backside Company that built this bridge. Similarly to the bridge, the Williamsfield Bridge that I've uploaded in my last video, that bridge was also built by the Windalco Backside Company. So based on what I've known that the Windalco Backside Company is no longer in operation. That establishment has been closed down since 2009, back in the recession, and I don't think it has restarted operation. So that's the Windalco, or the Alcan Kirkvine plant, that has been closed down since. So it has been it has impacted the Williamsfield community economically in a negative way. So it has had a negative impact on the Windalco community. So let me show you what this type of bridge is. Um, this type of bridge is a corrugated steel arch bridge. So it's a corrugated steel arch bridge. So let me take you closer, and if you notice, there are pedestrian walkway beneath the bridge, so pedestrian can walk underneath the bridge without interference with traffic. So if you look to the right, that's the wing wall. So over a period of time, the original wing wall has stopped at a certain point, and because of the soil erosion, they have extended the wing wall using gabion basket walls. So that is on the right side. So if you look on the left side as well, similarly, they have extended the wing wall with gabion basket retaining wall. So I've done a lot of gabion basket retaining walls, as well as rubble retaining walls. So I don't know if I can get to any one of those projects to show you what I have done. So yeah, so let me take you under the bridge and show you what the corrugated metal sheet is like. So this is the corrugated metal sheet. So the reason why they have employed this type of bridge, it is cheaper, it is economically feasible, and it is easy to install. So There are several ways how you can install this arch corrugated metal sheeting bridge. Um, you can use what is called a Bebo arch. I think I'm going to show you one of my bridge plan with Bebo arch and a corrugated metal sheet bridge. So as I said before, it is easy to install and it is economically feasible. It is cheaper than using the bulb T beam or the steel beam or steel girders. So the another name for the metal sheeting, it is called stay in place forms. So this forms, the metal sheeting forms the formwork for the concrete. So what has happened is that the reinforcement is put over the corrugated metal sheet and the concrete is poured over that to form the deck, the deck structure on which the road pavement or the pavement goes on top for vehicle to traverse. But as you can see, this bridge here, along with the Williamsfield Bridge, because of the closure of that Windalco plant, these bridges are not utilized very, very often. Probably it's not been utilized since 2009, I don't know. But when I was in Jamaica back in the early 2000s, before 2009, I could have seen vehicle going across these bridges. Both the one in Williamsfield and this one here. So let me take you back to the installation now. So yes, I said before, the reinforcement is placed on top of the corrugated metal and the concrete is poured on top of that, right? And I think it is equipped with shear studs. So the shear studs is there to allow the corrugated sheet metal to be composite with the concrete. So the concrete and the sheet metal, the corrugated sheet metal, it becomes composite, so it acts as one unit. So as you can see at the base here, it is bolted. I can't see it now because there's this concrete plinth that is there. It is bolted to the footing and it is poured with concrete. So if you notice, there's a bolt right here. These are bolts right here. And it is bolts really, really tight and secure. So it is bolted to the footing and forms the arch, right? So those holes that you see at the top there, as I said to you before, those are weep holes, and those holes are placed there to release the water or the what is termed as the hydrostatic pressure that is going to be built up behind the wall, so that it doesn't affect the bridge. It doesn't seep down to the foundation and cause settlements and can cause can cause crack in your wing wall or crack in your abutments or any form of concrete structure that is going to be affected due to the difference in settlement. Yeah, so your Gabion basket wall there. So let's move to the other end. So similarly, at the other end, you can see the extension of the wing walls using Gabion baskets. So I think over a period of time they have recognized that the soil is coming down behind that portion, coming down in the streets, and you do not want soil to be eroding down in the street, and that can impact on vehicular traffic and cause severe accidents, and these drivers, they use the road, they use the road very, very hard. They drive very, 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 very hard. So any little obstruction, especially the taximen, any little obstruction can be catastrophic. So yes, so you can see the wing wall is being extended by using gabion basket wall on the right. Similarly to the left here, the wing wall is being extended by using gabion basket wall. So yeah, so this is the look at the other end. So it looks pretty good. As I said, this bridge since 2009 is not being utilized. They are not coming under a lot of stress. When it was in operation, when the Alcan plant or the Windalco plant was in operation, there was not many traffic on this bridge. It was probably the truck transporting like the bauxite or probably, you know what I mean. So it's not heavy traffic. So it's not a bridge that come under heavy traffic. So light traffic, but you can see that it is well designed, as you can see, right? So yes, I was going to mention something. Yeah. So this is a steel. This is a corrugated steel arch bridge, and I'm emphasizing that they use this bridge a lot in America too. Especially when we use them as culvert going over water, and we use them as tunnel for train to go under, especially if the train is going under a road. This type of structure is utilized. So it is a steel, it's a corrugated steel arch bridge. There's another type to this one, a similar. It is known as beaver arch. But the beaver arch, it comes in precast concrete molds, and they just fit it over the arch itself. It forms an arch over, and it comes with slots that you can screw. You can screw the components, the concrete components together to form the arch. So yes. So I'm not gonna be long with this bridge here. So let's walk through one more time to show you. And as you can observe here, there's a few of the nuts. That's a nut here that is missing. So I've not observed many of the nuts missing. There's another nut here missing, and this one is even loose. So yeah, but you're going to find that over time, you know what I mean, because of the stress that is behind the arch. Some of these nuts are going to be loosened, and probably it is not maintaining as how it's supposed to be, because the bridge is no longer utilizing by any units, any of those heavy units, Alcan heavy units. So that is it for this bridge. And this bridge, let me emphasize again, it is the Melrose bypass. It is the Melrose bypass underpass bridge. So usually in the States we have a program by the name of APRAS. Whenever time any unit of a certain height is going under the bridge, it has to go through that system. It has to be granted a permit to go under the bridge, because if the unit is too high, it's going to hit the bridge, and hit the bridge, it can compromise the structure and it can cause failure. And we do not want that. So that is it for this video, just showing you the Melrose bypass corrugated steel arch bridge. Thank you for watching. Thanks.